Welcome back to the deep dive. So look, if you're building robust applications, especially with Node.js, you know the real challenge often isn't the happy path. It's managing failures. Things will go wrong. But the standard way we handle this, exceptions, try-catch blocks, it often just creates a mess.
Yeah, it leads to really unpredictable control flow. You get these failure points hidden deep inside the code, completely invisible to the caller. It feels like you're just hoping something somewhere catches the error. So our mission today is to really dig into why that classic exception model can be so flawed, particularly in async JavaScript, and explore a cleaner, more functional way, the result pattern.
Absolutely. And this is really important for you, the developer listening, because this pattern fundamentally shifts how you view errors. Instead of these invisible bombs waiting to go off, errors become explicit. They become type safe. They're actually part of the function's signature, part of the return data. Okay, right. So let's unpack that chaos a bit. The standard Node.js approach, especially with async stuff and promises, we tend to just throw an error when things go bad and then maybe wrap an await in a try-catch block way up the call stack.
Exactly. That's the default playbook.
And this follows that fail-fast principle. Sounds good on paper, doesn't it? Stop immediately if something's wrong.
It does sound noble, yeah. Terminate right away.
But in practice, especially with JavaScript being so dynamic, wow, it can introduce some serious ambiguity. I mean, I once spent like 3 hours chasing a bug, turned out some low-level utility through an error, but it got swallowed silently by an unhandled promise rejection somewhere else entirely. Total silent failure. Nightmare.
That is exactly the kind of pain we're talking about. The core drawback is, well, discoverability, or lack thereof. The person using your function needs to know what exceptions they might need to handle, but there's absolutely nothing in the function's signature telling them that. It's not advertised at all.
Right, hidden information.
Yeah, we call it invisible error handling. And it's just asking for trouble, really. It creates huge opportunities for bugs because the calling code just doesn't know what to prepare for. Your application becomes unpredictable because exceptions cause this non-local exit, right?
Yeah.
The control flow suddenly jumps maybe multiple functions up the stack, far away from the actual problem.
So you're constantly second-guessing. Is this function going to blow up? Is that one...
Exactly. You're left to guessing.
And this isn't just us complaining, it's a real thing in the community. I saw a comment from Raul Junco talking about this reliance on exceptions for control flow. He said, it really messes with the logic and breaks the natural flow. He basically called it a major source of complexity because, like you said, developers are left guessing what might throw and where.
That constant mental tax.
Yeah.
That's what we want to get rid of.
And that shared frustration, that collective sigh, it leads us straight to this critical dividing line. We need a good rule of thumb, something practical, for deciding when to use exceptions versus when to use something like this functional pattern. Okay, so what's the rule?
Well, you really need to differentiate between two fundamental types of errors. First, there are the errors you know how to handle. These are the expected bumps in the road, part of the normal operation almost.
Like what? Give me an example.
Okay, think about a user trying to log in with the wrong password. That's a validation error, right? You expect that might happen.
Sure.
Or maybe a database query correctly finds nothing because, well, the requested user doesn't exist. It's not a system crash. It's an expected outcome you need to deal with.
Okay, expected failures. Got it. What's the second type?
The second type are the errors you don't know how to handle. These are the truly exceptional, unexpected, often catastrophic problems. We're talking like memory errors, the database connection vanishing mid-query because the network dropped, or some third-party library just completely failing in a way you can't recover from. Things that mean the system itself might be unstable.
Right, the real disasters. The stuff you can't reasonably plan for in your application logic.
Exactly.
So with that distinction, how does it change how we use exceptions?
It means we radically refine their role. Exceptions should only be for those errors you don't know how to handle. The truly exceptional stuff.
The system-level failures.
Yes. And when you do encounter one of those, the best practice is usually to catch it as low down as possible, log everything you can about the state, and then probably let the process crash gracefully, maybe have a supervisor process restart it. These should be rare events, though.
Okay, exceptions are for the genuinely exceptional. Where does the result pattern fit in then?
It's built specifically for the other category, the errors you do know how to handle, the expected failures.
Oh.
By using a result type, you're explicitly signaling your intent. You're saying, look, this function might fail in these known ways, and if it does, here's the information about that failure.
So it makes those anticipated failures totally obvious, self-documenting almost.
Precisely. discoverable right in the function signature.
Mm.
And what's really cool here is the philosophical shift. It's fundamental. We stop treating errors like control flow grenades and start treating them like, well, like data.
Errors is data.
Exactly. The result pattern makes errors explicit, makes them type safe. The key idea is errors become return values, not things that hijack the execution path.
Okay, how does that actually work mechanically?
So in a language like TypeScript, instead of doing throw new error, your function returns a special kind of object. Often it's a generic type, maybe something like result TE.
Okay, result TE. What are T and E?
T is the type of the data you expect back if everything goes well, the success value. And E is the type that describes the error if things don't go well, the failure value.
So this result thing is like a container, a wrapper.
Yeah, think of it like an immutable box. Inside that box, there's either the successful data, the T, or there's the failure data, the E. And that E isn't just a string. It's usually a structured object with details about what went wrong, like an error code, maybe a message, maybe the data that failed validation. It's rich information.
Okay. But wait a second. If errors are just data, just return values, aren't we kind of going back to the bad old days? Like returning integer error codes in C where you had to look up what NECA1 meant?
That's a really good question.
Mm-hmm.
Why is this better than just returning, say, null or an error code?
Yeah.
The difference is the structure, the type safety, and the context. With those old C error codes, all you got was a number. You had no context. You had to look it up somewhere else. Here, the E in result TE is a proper typed object. It could have multiple fields, maybe an HTTP status code, and a user-friendly message, and an internal error type identifier, all clearly defined.
Okay, so it's much richer than just a code.
Way richer. And crucially, because it's a value, you get all the benefits of functional programming. There are libraries out there, like TS results or never throw for node, that give you helper methods. Things like .map, .flatmap, or chain.
Like you have with promises or option types.
Exactly like that. So you can chain operations together. You can say, do this, then if it succeeded, do that. Then if that succeeded, do the next thing.
Yeah.
And if any step fails along the way, the chain short circuits, and you end up with the first error that occurred, all without deep if-else nesting. It keeps the code clean.
Okay, I can see how that chaining would avoid a pyramid of doom with error checks.
Definitely. It lets you handle the error path gracefully alongside the success path.
So, thinking about the bigger picture, like software architecture, what are the concrete wins here? Especially using TypeScript.
Well, let's take an example signature. Imagine a function. Async, function, get user. Promise result user, not found or validation error.
Okay. Promise result user, not found or validation error.
Right. Just by reading that signature, you know several things immediately.
It's async, obviously. Returns a promise.
Yep. And inside that promise, you'll get a result. If it's a success, you get a user object.
And if it fails, it explicitly tells me it can fail with either a not founder error or a validation error.
Exactly. It's right there in the type. No hidden exceptions you need to guess about. Static analysis tools love this. Your future self maintaining the code loves this.
That's a huge improvement over just promise user, where it might secretly throw 5 different kinds of errors.
Massive improvement. So, benefit 1. No more non-local exits throwing your control flow off course for expected errors. Benefit 2. Self-documenting code. The signature is the documentation for failure modes. If you change the possible errors, the compiler will likely force you to update the calling code.
Which prevents bugs down the line.
Absolutely.
Yeah.
And it really helps in the async world of JavaScript. Using results inside async await makes composing asynchronous operations much safer than relying on try-catch for everything. The failure just propagates cleanly as a value.
Okay, that sounds really compelling. What about testing? Does this help there?
Ooh, testing is where this pattern really shines. It pays dividends almost immediately.
How so?
Think about testing a failure path with exceptions. You often have to do awkward things like mocking a dependency to specifically throw an error at the right moment. It can be quite fiddly.
Yeah, setting up those exception scenarios can be a pain.
But with the result pattern, if you want to test how your code handles a validation error, you just make one. You create a result, failure, new validation error object, and have your mock return that directly. You're mocking a simple, predictable value, not simulating complex, disruptive control flow.
That makes sense. Your test setup becomes way simpler. You're just checking how your code reacts to a specific return value.
Dramatically simpler and more reliable. But look, we need to be balanced. No pattern is a silver bullet, right? There are trade-offs. The result pattern isn't perfect.
Okay, what are the downsides? Let's hear them.
The most obvious one is probably verbosity.
More code.
Yeah, potentially. You are wrapping your return values in this result object,
Yeah.
and you do need to explicitly handle the success and failure cases. If you don't lean into those functional chaining methods like map and chain, you can end up writing a lot of if result.isSuccess or if result.isFailure checks.
Right. I can see how that could get nested and ugly if you're not careful. Like if I call 5 functions in a row that all return results.
Do you have to check after every single one?
Yeah.
Well, that leads directly to the second trade-off, which is kind of the point, actually. The mandatory check.
Mandatory check.
The caller had to check if the result was a success or a failure before they try to use the success data.
Because if you don't check and it was actually failure.
And you try to access, say, result.value.username when value is actually an error object, boom, you get a runtime error, probably a type error.
So you could accidentally cause an exception while trying to avoid exceptions. That's ironic.
It is, but think about it. Is this mandatory check really a drawback? Or is it a feature?
How is it a feature?
We sometimes call it positive friction. The pattern forces the developer, right there at the point where they call the function, to acknowledge and handle the possibility of failure.
So it prevents you from just forgetting about the error case or having it silently swallowed like we discussed earlier?
Exactly. It makes error handling explicit and non-optional for these known failure modes. It prevents the very problem of invisible, unhandled errors that motivated this pattern in the first place.
Okay, I see. The verbosity and the mandatory check are the price you pay for explicitness and safety.
That's the trade-off, yes.
Yeah.
You trade implicit, potentially unhandled exceptions for explicit mandatory value checking.
So wrapping this up for someone building systems in Node.js today, what's the core message, the big takeaway?
I think the main thing is clarity of intent. Be deliberate about errors.
Use exceptions only for the truly unexpected, the system-level catastrophes you can't plan for.
Right. And for everything else, all those anticipated failures, the validation errors, the not founds, the permission issues, anything that's part of the normal, albeit unhappy flow of your application.
Use the result pattern for those.
Yes. Make them explicit return values, make them obvious, type-safe, self-documenting parts of your function's contract.
And the benefit is better code quality.
Better quality, definitely. More predictable code, clear expression of intent, and ultimately applications that are just easier to reason about, easier to maintain, and importantly, easier to test, especially in complex async code bases.
Fantastic. Okay, so here's a final thought for you, the listener, to maybe chew on as you go back to your own projects. If this result pattern is really the better way for known failures, does that imply a pretty radical refactoring? Should basically every function that talks to the outside world network database file system return a result? Are we moving towards a future where success and failure are always treated with the exact same level of explicit upfront care in our function signatures? That's definitely something to mull over. We'll catch you on the next deep dive.